Chapter 9, Periodic Properties of the Elements. And this begins with a quote from Isaac Asimov, science fiction writer. Beginning students of chemistry often think of the science as a mere collection of disconnected data to be memorized by brute force. Does that sound about right? Yeah, not at all. Just look at it properly and everything hangs together and makes sense. Well, that's easier said than done. But if you're persistent and try to put these pieces together, it does hold together. Now, I'll be honest, I don't think it really held together for me until I finished my master's degree and was going to teach my first chemistry class. And so I'm going through the general chemistry book, taking notes to try to explain this to my students. And then it suddenly made sense. And I was like, oh, wow. And it just all came together. So, yeah, might not happen this semester. Development of the periodic table. Mendeleev is generally given credit for this. He ordered the elements by atomic mass. We've talked about this. The periodic law says when we order the elements by increasing mass, we have certain properties that recur periodically. He used the patterns that he observed in this table to predict the properties of undiscovered elements. And there are at least two places where atomic mass didn't fit with the other properties. One example is tellurium and iodine. So if we look here on the periodic table, tellurium has a mass of 127.6. Iodine is to the right of it, and its mass is 126.9, which is smaller. So by mass, they are reversed in order, but he put them in this order because that's how their properties said they should be. And then later, it was discovered that the proper ordering was by number of protons, not by mass. And so those are in order by number of protons. So this is just an example of some of the predictions that he made about some elements that were not discovered at the time, and then comparing that to the actual properties. He did really an amazing job. So Mendeleev's periodic law is a law. It tells us what happens, but not why. It allows us to predict what the properties are, but doesn't explain why the pattern exists. Quantum mechanics is a theory that explains why those patterns exist. So knowing why allows us to predict what, and that is much more powerful.